Hello, this is Y.E. Tanner from Electronic Thinking, and I wanted to show you the importance in this video of putting capacitors from your power supply terminals to ground. So I've taken the digital storage oscilloscope circuit here and I've changed it around quite a bit in an attempt to get this first section to work. So I've drastically reduced some of the complexity over here, taken the switch out, trying to remove as many non-essential components as possible, making it as simple as possible to try to eliminate any problems and see where the errors were coming from. And one of the things that I noticed was that the power supply lines were a big contributor to the noise that was coming into the circuit. And when I put in a couple 10 microfarad electrolytic capacitors right here and here from the 12 volts to ground and from the negative 12 volts to the ground, and watch your polarity on these, because we might typically be used to putting the negative side of the electrolytic capacitor to ground, which you do for the 12 volts, but for the negative 12 volt side, the negative side goes on the negative 12 volt side instead of to ground, because it's at a lower voltage potential than ground. So I wanted to show you the difference that this has made in the circuit. And so I have the oscilloscope here with the output waveform. This is a 100,000 hertz signal coming in at about what is that? About 400 millivolts. So I have this set at a scale of 100 millivolts per division in the voltage scale there, in the vertical scale, and it's coming in at 100,000 hertz. So let me take off one of these capacitors, and you can see already the difference that that is making. And watch what happens when I take off the other capacitor. Okay, let me pull it off here. It's kind of sticking to the breadboard. There it goes. Now, what I want you to look at here is all of this noise that is just, you see all these oscillate, they just kind of flow along here. And that was what I've been struggling with, trying to remove all this noise, trying to find the source of all of this noise. And I tracked it down to, let me just move this right here, is looking at the output. Let me just put that for a moment here on the negative 12 volts. And look what we have on the negative 12 volt supply. If I turn this horizontal, you can see these spikes that are coming in at very regular intervals on the negative 12 volt supply. And that's what those 10 microfarad capacitors are removing from that supply line. So let me put in one of those capacitors. I'll have to move the scope out of the way to see how I've got this oriented here. And I won't put it in yet, I'll kind of put the scope here. And there you can see I've made contact with it. Let me break that connection. And you can see the spikes come back in. I put it back in here. And there the spikes disappear. So you can see those spikes actually disappear from that negative 12 volt supply. So what a difference those capacitors really make. And I thought that, of course it's always a good design to include those capacitors across your power supply voltages, but I thought that was such a good example of the benefits that you would get from actually including these electrolytic capacitors across your power supply lines like that. So that is all for this video. I just wanted to to just cannot iterate enough the importance of putting those electrolytic capacitors across your power supply lines.